Welcome to the PA-DEP video tutorial series on non-community water system application approvals. In this series, we will review the various components and requirements of the new approval process for non-community water systems. This video will cover Module 5, Water Storage. Module 5 is intended for any non-community water system that is installing or modifying water storage vessels for their system. The applicant should list all information about all water storage vessels in the 3 tables at the beginning of Module 5. If the tanks are identical, only one of the 3 tables should be completed, and the number of identical tanks can be noted in the table. If the system has more than 3 non-identical tanks, print and attach an extra copy of this module with only the top portion filled out for any other tanks. Complete the table or tables and include the vessel manufacturer, type, number, volume, diameter for round vessels, or length and width for rectangular, maximum water height, and location. The volume should represent the maximum volume as per the manufacturer's specifications, or can be calculated by using the vessel dimensions and the maximum water height of the tank. Location should be given in degrees, minutes, and seconds to 4 decimal places, or can be a simply worded description of the location within the treatment system. By standing near the location of the tank, most smartphones will provide you with a latitude and longitude location. Section A is for general requirements. Storage vessels should allow for a minimum working pressure of 35 psi. Reservoirs, standpipes, and elevated tanks shall be provided with watertight roofs or covers to prevent contamination. Storage structures shall be designed to prevent freezing. Facilities using pressurized storage tanks should be provided with pressure relief valves and air volume controls to ensure the tank maintains proper pressure and does not rupture. Vents should be protected with down-facing elbows or mushroom-type caps covered with 24 mesh screens to prevent rain or insects from recontaminating the water. Coatings and liners should be certified as per ANSI NSF Standard 61 to ensure they do not leach any material into the drinking water. Total storage capacity of the vessels should not exceed 5 times the system's average daily demand to prevent water stagnation and ensure proper disinfection residuals. Fire flow systems should be separate from the potable water system. If separate systems are not possible, facilities should be designed to minimize water age while maintaining adequate disinfection residual at all times. If using a combined potable and fire flow system, the non-community water system must still be able to maintain 0.2 milligrams per liter of free chlorine disinfectant residual throughout the distribution system and in storage vessels. This may be difficult if large quantities of water are kept on hand for fire flow that is not used. Unused water may stagnate and lose chlorine residual within a vessel. Beginning April 29, 2019, a non-transient non-community water system that has installed chemical disinfection, or a transient non-community water system with either a surface water or groundwater under the direct influence of surface water source, or with 4-log disinfection of viruses for a groundwater source, must maintain a minimum disinfectant residual concentration throughout the distribution system, sufficient to ensure compliance with the microbiological MCLs and all treatment technique requirements. The minimum disinfectant residual concentration required by the Disinfection Requirements Rule is 0.2 milligrams per liter, or another level approved by the Department for systems using an alternate oxidizing treatment. This minimum residual concentration ensures that water reaching the furthest points in the distribution system is disinfected adequately. All storage facilities should be disinfected in accordance with AWWA Standard C652 to ensure the storage facility itself does not cause contamination. Section B is for elevated or standpipe storage. If this section is not applicable, select NA and continue to Section C. Elevated or standpipe storage should be considered if usage will exceed 30,000 gallons per day because it may be the simplest way to provide pressure. Storage volume should be between 1 and 5 times the average daily demand to ensure adequate supply while also minimizing stagnation and loss of disinfectant residual. All tanks should be constructed per appropriate AWWA standards. These standards ensure the tank is designed and constructed specifically for potable water storage. Tanks should be painted according to AWWA standards using ANSI NSF Standard 61 certified products. These methods and certified products ensure that the products are safe to use for potable water and are applied in a manner that will not compromise drinking water quality. Water levels in storage vessels providing pressure to the distribution system should not fluctuate more than 30 feet. Variations greater than 30 feet can cause extreme pressure spikes and losses. Non-pressurized tanks should have an overflow which empties at an elevation of 12 to 25 inches above ground surface to allow for more easily controlled discharge. This should be discharged over a drainage inlet or splash plate. All overflow pipes should allow for the discharge to be visible. All overflow water disposal shall be consistent with the Clean Streams Law requirements. More information on these requirements can be found by selecting the link below. Internal overflow should be located within the access tube. For vertical drops, the overflow pipe should be located on the outside of the tank. Overflow pipe diameters should allow for discharge in excess of the maximum filling rate to ensure tanks will not rupture during an overflow event. Elevated tank overflows should open downward and be screened unless a duckbill valve is used to prevent recontamination from insects. Tanks should include entrance hatches, a screened vent, and OSHA-approved access ladder to ensure safety. Hatches are necessary to enter the tank for cleaning, inspection, and repairs. Vents are necessary to equalize tank pressure. All piping and valving should allow the tank to be removed from service when necessary, as tanks may need to be taken offline for cleaning, inspection, and repairs. Tank drains should be provided in order to empty the tank as needed. Sample lines and taps should be provided to sample water directly from the tank even when out of service to ensure an accurate and representative sample of the water within the vessel. Overflows shall not have a direct connection to sewer and storm drains in order to prevent cross-contamination. Security measures should be provided, including locks on access hatches, ladder locks, chain link fencing, security alarms, and cameras. Low tank level warning lights or alarms should also be provided. These indicators help ensure that the tank is maintaining adequate volume to meet demand or providing enough contact time for proper disinfection. Suitable control systems, such as telemetering, should be provided as well in order to transmit the data to operators that are not on site. Section C is for hydropneumatic systems. If this section is not applicable, select NA and continue to Section D. All hydropneumatic tanks should meet the ASME code requirements. Hydropneumatic tanks shall not be used for disinfection contact time. For contact tanks, please complete Module 2, Treatment. These tanks should be located entirely above ground surface to prevent possible flooding and housed with adequate heat. All hydropneumatic tanks should be located after all treatment systems and after any required chlorine contact time is achieved, as hydropneumatic tanks will not receive contact time credit and may cause spikes in flow. If these tanks must be located before disinfection, a flow controller should be utilized to ensure adequate contact time is provided in the contact vessel following the hydropneumatic tank. The gross volume of the tank in gallons should be at least 10 times the capacity of the largest pump in gallons per minute, unless the system has other ways of meeting the maximum demand. All hydropneumatic tanks should have bypass piping to permit system operation when working on a tank. Each hydropneumatic tank should have a drain and control equipment to include pressure gauges, sample taps, air blow-off, a way to add air, and pressure-operated start-stop pump controls. Pressure relief valves should be installed that can handle the full rate of flow at the pressure vessel design limit. Manholes or entry hatches should be provided if practical to allow for inspection of the tank and bladder. Sample taps should be provided and located at least 6 inches above the floor in a location that allows operators the ability to fill sample containers. Section D is for ground level storage. If this section is not applicable, select NA and continue to Section E. Ground level storage should be above the normal groundwater table and above the 100-year floodplain. You can find more information on the 100-year floodplain by selecting the link below. Storage should be constructed at least 50 feet from sewers, drains, standing water, and other sources of pollution to prevent possible contamination. Tanks should be watertight and constructed to prevent entry of animals, insects, and excessive dust to prevent possible contamination. Fencing, locks, and other security measures should be provided. Direct connections to sewer and storm drains shall be avoided. An inverted U-shaped screen vent should be provided to equalize pressure and prevent possible contamination. Access manholes should be above the water line of the tank. The access manhole should be framed at least 4 inches above the surface of the roof and fitted with a solid, watertight locked cover which overlaps the frame. Screened overflows should be provided with an air gap of at least 12 inches above a splash block at ground surface. Air gaps help to prevent against possible contamination. Direct connections to sewer and storm drains are not permitted. Land should be graded so that surface water will drain away from the tank. Section E is for fiberglass storage. If this section is not applicable, select NA and continue to the next section of the module. If the system is using fiberglass storage, the proposed tank should still follow all applicable standards in Section A and Section D of this module. Pressure testing and soap bubble testing of the fittings should be completed prior to the use of the vessel to ensure the vessel is watertight. Tanks should be anchored to a concrete pad and backfilled with pea gravel meeting manufacturer's recommendations to prevent the tank from floating in the event of a flood. The combined weight of the empty tank, concrete pad, and backfill supported on the pad should be sufficient to prevent flotation of the empty tank. The last section of Module 5 is to address all no answers in the module. If any of the questions in this module were answered no, this section must be completed to explain those no answers. Enter the question number from Module 5 and then enter the explanation or justification for selecting no. Lastly, look over the module one final time for completeness before submitting. If all of the questions answered with no have been addressed, check yes here. Up next in the series is Tutorial 8, which will cover Module 6, Distribution Systems.